All right, let's dive right into this. Welcome to today's Explainer, where we are unpacking a genuinely fascinating blueprint called Exocore 26. We're going to be looking at the May 2026 architectural update of a dynamically evolving system. Now, at its heart, Exocore 26 is a passive income and task generation engine. But what makes it so incredibly unique is the hyper-localized, really scrappy way it's been built. If you're someone who loves clever engineering and totally resourceful network topologies, you are absolutely going to love what we are unpacking today. Let's get started.
Okay, what's truly mind-blowing here is exactly who this source document was written for. It's literally an instruction manual designed to be fed into autonomous AI chat agents. I mean, talk about breaking the fourth wall of software documentation, right? The human developer is essentially grabbing the AI by the collar and saying, "Stop, look at this state of truth, and whatever you do, do not assume we have standard cloud hosting." It's just this incredibly modern, brilliant way of setting strict parameters for an AI copilot, making totally sure the machine understands the rigid, highly specific environment it's actually coding for.
So here's our roadmap for today's Explainer. First, welcome to Exocore 26. Then, the Zero Cloud hardware strategy. Third, inside the 3 nodes. Fourth, latest security and system wins. And finally, we'll wrap up with the next evolution phase.
Welcome to Exocore 26, redefining the MacGyver tech stack.
So, the absolute core philosophy driving this entire project is what's called the Zero Cloud Dependency Principle. Think about it. In an era where literally everyone just defaults to renting expensive AWS servers, Exocore 26 actively rejects external cloud infrastructure. Instead, it aggressively prioritizes local hosting. And how? By using everyday mobile devices acting as application servers through Termux, which is a Unix emulation environment. The really crucial takeaway here is that the system creates an incredibly resilient, totally private, and basically zero-cost local network. It is entirely self-sustaining, giving the developer ultimate autonomy and, of course, saving a ton of money on infrastructure costs.
Moving on to Section 2, the Zero Cloud hardware strategy. Constraint breeds creativity.
Now, you might be wondering, why on earth would they build an entire server ecosystem on mobile phones? Well, as they say, necessity is the mother of invention. It turns out, a massive motherboard overcurrent failure on the developer's main workstation is what forced this entire evolution. Rather than pausing the whole project for weeks to buy expensive new hardware, the developer made this incredibly scrappy survivalist pivot. They just scaled the entire execution ecosystem down so it could run fluidly across low-spec mobile units and whatever legacy hardware they just had lying around. So that hardware crash, it wasn't a project killer at all. It was actually the exact spark that forced them to optimize memory overhead and completely rethink how they deployed applications.
Section 3. Inside the 3 nodes. Mapping the hardware. Check out how distinctly the labor is divided across 3 actual physical devices here. First up, we have the TCL 501 node. This is a super resource-constrained Android, and it acts as the task injection web gateway and Telegram bot router. Next, there's the Samsung A05 node, another Android, which steps up as the primary local data store. This is the absolute source of truth for the local network. And finally, we have the Dell Inspiron 13 node. With just a basic Intel processor and a meager 4 gigs of RAM, this older, stateless laptop takes on all the heavy processing, the computational tasks, and the code authoring. Every single repurposed device has a highly specific, optimized role.
I love how they visualize this to make it easier to grasp. The TCL phone is basically the bouncer. It literally stands at the perimeter, handling web requests and checking IDs. Then the Samsung phone is the vault. It catches the data, processes it through Python and Flask, and securely locks it into the local ledger. And that Dell laptop, that's the heavy lifter. It runs all the localized data crunching using tools like NumPy and Labrosa, and then syncs everything back perfectly using syncing. It's just this beautifully orchestrated trio.
Okay, let's trace how a piece of data actually flies through this setup, because it's super fast. The system brilliantly separates the data input from how it's ultimately presented. Step 1, a command signal hits the insulated user input dashboard. Step 2, it shoots through a Servio secure SSH bridge to safely reach the local network. Step 3, boom, it hits the Node.js perimeter gateway right on our TCL bouncer, where it gets mapped and authenticated. And Step 4, it's immediately dispatched via the Telegram API to a highly available cloud channel, so the user can just look up and see it on any TV or laptop screen. It's this incredibly rapid, asynchronous firing of data packets, straight from a highly insulated local web app right out to a secure Telegram feed.
Section 4. Latest security and system wins, the May 30th patches.
Now, taking this architecture public wasn't easy. They had to fix a massive roadblock. Originally, using standard ngrok tunnel software inside that Termux Unix subsystem was triggering immediate memory crashes, nasty segmentation faults, all because of compilation discrepancies. It was a totally unstable nightmare. So how did they fix it? They just bypassed those defective binary resolvers entirely by switching over to Servio. By mapping the local port out over standard SSH rules that are actually natively supported by Termux, they achieved a rock-solid zero-configuration reverse proxy tunnel. Problem solved, and they didn't have to write a single line of bloatware to do it.
But obviously, any public endpoint needs a guard, right? You can't just leave the door open, which is exactly why they implemented this incredibly strict gatekeeper PIN verification schema. To stop open internet scrapers and unauthorized task injections dead in their tracks, the standard JSON payload contract now strictly requires a PIN. The Node.js server takes that and validates it against a hard-coded master_PIN. If it's a match, awesome. The user gets a success receipt and a little green confirmation flash. But if it fails, or if someone doesn't even send a PIN, that request is instantly dropped right at the perimeter edge. The system just spits back a 401 unauthorized status and logs the intrusion. It's a lightweight but highly effective security checkpoint.
And that brings us to Section 5, the next evolution phase, the ExoCore 26 Toto pipeline.
So, what's next? Well, here is the exact to-do pipeline currently being fed to the AI agents for the next evolution of the system. Phase 1 is persistence optimization. The immediate next step is dropping a lightweight SQLite database right into the local project folder on that TCL node. That way, they can safely back up every single incoming payload without needing any heavy installations. Phase 2 is local network synthesis. This means fully automating the handshake, so the second a task passes that PIN challenge, the TCL node fires an internal asynchronous HTTP post payload straight over to the Samsung Vault to log it permanently. And Phase 3, man, this is the really fascinating part, audio automation UI. The end goal here is to build interfaces that literally trigger Python signal processing engines sitting over on the Dell laptop to analyze actual guitar audio and push automated tablature notation straight to the user dashboard. How cool is that?
We have really seen how ExoCore 26 managed to take a catastrophic hardware failure and turn it into a localized, highly secure, zero-cloud ecosystem spanning repurposed mobile phones and legacy laptops. I mean, it successfully processes tasks, it strictly secures payloads, and it's literally on the verge of writing guitar tablature entirely in-house. So I want to leave you with this thought as we wrap up today. As systems like ExoCore 26 continue to prove that we can absolutely eliminate the cloud for personal engineering and passive income generation, what kind of boundless, scrappy potential will localized AI automate for us next? Thank you so much for joining me on this explainer. Keep exploring, keep learning, and I'll see you on the next deep dive.